process with some aid, some help from us, brushes and things like that. One type of chemical product that we use is called an enzyme. So enzymes are, there's three main categories of enzymes that we use. Protease enzymes remove or help to remove, they break down blood, mucus species, and albumin proteins, protease. And then there's lipase. Lipo is fat, just like in liposuction. So lipase helps break down fatty deposits such as bone marrow and adipose tissue. So anytime there's a surgery, these two things get on the instruments. And then there's amylase, which catalyzes starch. So between these three enzymes, this is a good beginning to the cleaning process as far as being in decontamination. Remember, the beginning, the real beginning of the cleaning process should begin at the point of use. So you have your right? Your three types of enzymes. Now, those are used to break down tissues. Then you have detergents. So detergents should contain emulsifiers, surfactants, and chelating agents. An emulsifier helps to bind things together that don't normally combine. If you looked at a Snickers bar ingredients list, it would list something that is an emulsifier. Basically, it's something that can help things like oil and water combine together. You emulse them. A surfactant, which is something that lowers the surface tension of water. Have you ever seen a mosquito stand on water or a picture of it? Okay. If you lower the surface tension enough, that mosquito might sink. So detergents have to have surfactants. If you don't have a surfactant, then the water will not be very good at getting into these very tight places inside of these instruments because the surface tension, the same surface tension that allows a mosquito to stand on top of the water, can keep the water from getting into the tight places. And then chelating agents, which are chemicals that hold hard water minerals in solution and prevent soaps or detergents from reacting with the minerals. Chelating agents, know those three. So protease, lipase, amylase, emulsifiers, surfactants, and chelating agents. You should know those. What they are, what that means. And keep in mind, there are things called antibacterial or germicidal detergents, but the main purpose of a detergent is not to kill germs. So a detergent's only going to kill germs if it is germicidal. It could be something that is just germicidal that you're using, and it's highly relevant. So if the instructions for use on something says use a germicidal detergent, then you would. But any detergent on instruments should be able to remove the soils, making it safe to handle. So what detergents kill germs? Germicidal detergents. What is the main purpose of a detergent? To remove soils, not to kill germs. Okay, just a second. Okay, here we go. Detergents and pH. So notice on page 147, there are some bullet points regarding neutral detergents, which are the most commonly used, alkaline detergents, and acidic detergents. Now, each one of these has its own advantages and disadvantages. Pay attention to what those are. You may be required to use an alkaline detergent, perhaps by a manufacturer, or due to something wrong with your water or something, trying to change the pH. There are acidic detergents as well. But by and large, the most common, the most preferred is going to be neutral, because that is the least impactful, negative impact on the instruments and the machinery itself. Okay. Review of common chemicals used in the decontamination area on page 148. Keep in mind that each chemical is different and cannot be substituted for another. So a germicidal detergent cannot be substituted for a disinfectant. Also, you need to understand that you cannot make your own super cleaners. You wouldn't mix bleach and ammonia at your house. I hope you know that. If you didn't know that, that could release toxic chlorine gas into the atmosphere, killing you most horribly. You should not mix chemicals unless approved by the manufacturer of the chemicals. So no, you can't make your own disinfecting detergent by pouring disinfectant into detergent. Chemicals should always be used by the IFU. So if it says use 1 ounce per gallon, then that is how you mix it. Okay, there are pre-cleaning chemicals which are used at point of use. There are manual cleaning chemicals which tend to be high foaming. And then there are mechanical cleaning chemicals which need to be low foaming, because the mechanical cleaners, it's like the difference between Dawn and then the Cascade that you put in your dishwasher. The Cascade is low foaming, the Dawn is high foaming. There are descalers that it says that they're not typically required if the water quality and detergent mixtures are correct. But you know, you probably will find your washer starting to get a little bit frosty looking on the inside. If you see it happening on your instruments where they start looking frosty, that could be that you have too alkaline of a thing happening, or that that it's time to descale your washer. Of course, use the instructions for use, which are clearly printed on the bottle. Lubricants should always be used according to instructions for use. They're not appropriate for everything. The lubricant that goes into the washer and is fed into the final rinse, which takes place after the wash, we call it milk. We call it milk because it looks like milk. I don't know what it tastes like. So lubrication should always be the appropriate lubricant. Some items require something like a mineral oil. That would be really power equipment that requires that. All lubrication is performed after the cleaning is done so that you don't rinse the lubrication off. There are stain and rust removers that should always be used according to the instructions. If you're using a stain or rust remover, pay careful attention to the mixing and the amount of time that it's allowed to be in contact with the instruments. If you exceed that time, you could be damaging the instruments. Okay. Nice pictures on page 150 and 151. Read these pages. You need to read these pages. On page 153, there's a couple things I want to point out to you. It says disassemble multi-part instruments. You may not even realize that something is a multi-part instrument. So look for the secret. If it's something like this, it's not going to come apart unless it does. I tell you, I have seen scissors that if you open them up far enough and then you pull it, it comes apart. But they're actually, it's very obvious that it's that kind of scissors. I saw it one time in the 972 years that I've been doing this work. Okay. Lumens and cannulated items should be fully submerged, and then flushed with cleaning solution. This will force air bubbles out of the lumen and ensure that the inner surfaces are in contact with the cleaning solution. So it says that if available, placing lumened items in a vertical soaking cylinder also helps to ensure that air bubbles are not inside the lumens. Okay. Air bubbles will rise, right? Because gravity pulls the water down. Otherwise, you have to make sure that you take something that has a lumen and maybe inject some cleaning solution into it, or the way you place it into the water, and you go like that. Make sure that it doesn't have air bubbles trapped inside of it. that cleaning solution, if there's an air bubble inside of it, it's not going to contact all the surfaces. Where the air bubble is, the cleaning solution is not. Okay. Watch for lumens. Watch for lumens. Sometimes they hide in places where you don't expect it. So on page 154, where it says watch for lumens and it has those tiny pictures, there are 3 of these objects that you often see that don't have lumens, and then you'll see one that looks exactly like the one that doesn't have the lumens, but it actually has a lumen. Like the screwdriver in the top left corner, there's 2 screwdrivers there. There's lots of screwdrivers that don't have lumens, and then there's ones that are used in specialty sets where they need to have a lumen and may or may not be used with the lumen, but they're there, and you have to pay attention and check and make sure that you don't have lumens. And the crime scene on page 155. Orthopedic instruments are often loaded with gross soil. Those reamers that are sitting in that metal basin, it is not possible to wipe them off with a gauze sponge at the point of use. So you may see point of use processing, point of use preparation not being done on things like that, because if they tried to do point of use preparation on that, all it would really do would be to shred the gauze. Okay. Toxic anterior segment syndrome. I'm going to point something out about TASS, and that is that it is not necessarily a bacterial infection. TASS can be caused by something that's not properly rinsed after it's been cleaned. There's a little bit of detergent or something left on the instrument could cause an inflammatory reaction inside the anterior segment of the eye, which could lead to blindness. Now, it is treatable if caught soon enough. In this case, with ophthalmologic instruments, whereas with, let's say, an abdominal instrument, if just a tiny bit of detergent or the lubrication is left on an instrument, that is not going to cause the patient to go blind or even necessarily cause a reaction in the abdomen. Specifically of eye instruments, this is where TASS is a problem. So you may have special cleaning procedures for eye instruments in your facility. You'll definitely want to follow those. And the blue box, read the blue box. Page 156. This was in the Brown book. I talked about it. You know, you take instruments from backup, clean them. You don't know how long they've been sitting there. Dust does accumulate on those instruments in backup. Unfortunately, it's impossible to keep the department completely dust-free. Okay, cleaning instruments that cannot be immersed. It states here that instruments such as power equipment and cameras cannot be immersed in water. Well, I'm here to tell you that there are a couple examples where that is not true. With the Stryker cameras, the newer ones, the 1288s, the 1488s, and whatever they've come up with after that, it is actually necessary, according to the instructions for use, to soak them, to immerse them in the cleaning solution for a period of time. And in the beginning, that arthroscopic shaver that they had the borescope picture of, that item must be immersed. But you would go by the instructions for use. You can't just say, well, this camera can be immersed, or this power equipment can be immersed, so therefore this one can. And then vice versa, the other way around, you have to soak the arthroscopic shavers, and you must soak those Stryker cameras I mentioned. That is in the instructions for use, that it be done. Something like a pneumatic instrument, where it might use this air hose. This on page 157, that air hose is nice and curled up. It's a very dark color, like a very, very dark chocolate or black color. That hides blood very well. So that hose cannot be immersed, but it must be cleaned. And if it makes it into your decontamination room and it's all nice and curled up, don't ever assume that it wasn't used, because, like I said, it hides the blood. So blood just doesn't show up on it. You might see a spot on it that looks like, oh, look, the whole hose is shiny except for that one spot where it's kind of like flat. That's blood. Okay, the blood dried and it looks just like the rest of the hose. But if you get water or moisture inside of a powered surgical instrument, it can be very damaging to the instrument. So instructions for use, of course, and even if it has a cannula, you might not be able to immerse it. You still have to run water through it and cleaning solution and the right size brush, and then rinse it. Last thing I'm going to say on page 158. Now, is there any way to test something to see if it's been cleaned properly? You should know the answer to that. That was the beginning of this chapter. Okay. So that is it, the overview lecture for chapter 8 of the ISHM textbook.